mean, it's an option. We use it. I mean, how the directional answer to the exercise. It started off at like 400 something. It was like 400, and when you see it get dropped down, it was no 400, and then it dropped to 300, and then it finally stable that shoots over.
You guys ready? Maybe?
Yeah.
Look at all the stuff we get to do today.
What is it about this?
I don't know.
That's a lot of work.
We got like
Ambiguous overloading.
Yeah, ambiguous. Maybe a little ambiguous about what that is. So we're gonna talk about input today, which I think will just be good. Mostly not a refresher, but really new stuff of kind of how input works. Talk about streams, which you had to use it on your last lab, but you didn't really know how it worked or what it really did. So we'll get more of that today. And then we'll just kind of review functions and how we use parameters and return, how we do call by value versus call by reference kind of stuff. So we'll kind of get into that, which will be good because in your assignment that you should start to work on, right? You're gonna have to write functions. So functions are important for us, and so talking about them and kind of remembering how they work, is gonna be really important for us moving forward. Does that make sense? Anyone have any questions? We excited to be here? Yeah, sure, right? It's not that early. Feels pretty good. So let's talk about some input-output ideas. And one of the ideas we have is this thing that's called a stream, right? And so a stream, right, like IO stream, which is something we include, or like string, which we just kind of got thrown, right, at us last class, is really what we call, it's a flow of characters, or really a flow of data. Okay, so that's data coming into your program or data going out of your program. So we have input streams and we have output streams, right? Input streams, data is flowing into my program, and output streams, data is flowing what? Out, right? Pretty simple, right? Data comes in, data comes out, right? That's what we call IO, right? Input and output. Notice I define both of them as you can get data from a user or from a file, okay? So C in and C out, console input, console out, right? They get data from where?
The user, right?
The user, right, via the console, okay? But we can connect them to files, which we'll learn eventually. We can connect them to streams, which we're going to learn today. So there's a lot you can do with streams, and the nice thing is that they work the same, regardless of if you're reading from a file or you're reading from the console. So once we learn the basics, we can kind of translate that to anything that I want to read from or anything I want to write to. CNC out are both streams, right? They're defined in IO stream and created automatically for you when you, right, include IO stream. So CN, right, console input, that's how we get data from a user, right? The way it works is that when you do a CN, right, you get the little prompt, and the prompt, right, is just blinking, waiting for the user to type something. And the program doesn't continue to go until you do what?
Press return.
Press return, right? And also type something, right? Because CN is waiting for input from the user, you provide that input, you hit enter, and it brings in. Okay, so it doesn't read until you hit input. So technically your program could just sit there and run for forever if no one ever had hit enter. That make sense? And where do we say it went, right? When the user hit enter, where did the data go?
Variable.
Right, it went into a variable, right? That's what we said. Okay, so one thing that you're gonna learn this semester is that I lied to you previous semesters. Okay, because technically it doesn't go into your variable, it goes into this thing called a buffer. Okay, so streams are buffered, and so the data comes into your program and it goes into a buffer. And then eventually, but this obviously computers run so fast that it seems instantaneously, that data is transferred to a variable or multiple variables depending on how you wrote your CNC. Okay, so it goes to this magical buffer place, right? And that's because input and output operations are pretty heavy when it comes to CPU resources. And so we try not to do everything, right, individually, because that will slow things down. So we try to do things faster, so we create a buffer to bring that down. Does that make sense a little bit? Are you sad that I lied to you before? We'll bring that trust back eventually, maybe. So what does CN do? Really, CN pulls the first chunk of data from the input buffer. Okay, so CN pulls the first chunk of data right from the input buffer. I say chunk of data, but what do I mean? Characters, right? So it pulls in the first characters from the data. Anyone know where it stops? A space, right? And I'm going to make that broader and say white space. So white space is a literal space, a tab, or a what? New line character. Right, those are all white space. So it makes sense, you type something in CN and you hit what? Enter, which is a what? New line character. Right? Enter's how we get new line characters. So it reads to that new line character. So space, tab, or new line. Now, one weird thing CN does is it ignores leading white space. So you could do space, 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 hello, enter. Right, and what's it going to pull in? Hello. Right, it's going to ignore any leading, so it's at the beginning, and it stops at trailing white space. Okay, so it's fine. Ignores leading white space, stops at trailing white space. And one thing it does is it doesn't throw that white space away, so it stays in the buffer. All right, so that white space is in the buffer, but it's not that big of a deal because the next time you use CN, right, it ignores that leading white space and it continues on. Okay, we're going to get some examples of this as well. Right, so if I send into your name, right, and I type my name, right, I'm going to put a new line in there as well. All right, what's CN going to do? It's going to pull until what? It hits white space, okay? So this would be my buffer, right? These would all be characters in the buffer, right? And when I say CN name, right, that says pull from the buffer until you hit what? White space. So what goes into name?
Oof.
Does that make sense? So it removes those 4 characters from the buffer and puts them into my variable. So name now has the value Luke. What's left in the buffer? Right? This leading white space, that's still in the buffer, right? And then all the other characters I typed included a new line. Okay? So when I say, right, CN, right, value, right, and really what do I want to happen? I want the user to type in a value, right? CN's always going to look where first? In my buffer.
Oh.
Okay, CN will always look in the buffer first. If there's nothing in the buffer, that's when it prompts you to type something in. So what is going to go into value?
Uh-oh.
All that. And because we have types, right, value is probably an integer or a double or something like that, and what am I trying to put into it? A string, right? A bunch of characters. Does that work?
No.
No. And all of a sudden, your whole program's borked because it's not going to work.
Is there a way to clear the buffer?
Yeah, we're going to get there today.
Oh, okay.
Right? I'm presenting bad things. Now, if you want to get an entire line, right, we're going to call this, right, a line would be anything up into, right, a new line character. Right? We have a function to do that, and that's called getLine. GetLine allows you to get characters to a new line character. right? But you'll notice that get line works only with what?
Strings.
Strings, okay? So whereas CN works with what? Ints, doubles, chars, bools, strings, right? It's like magical, right? It's the not magical part is that if someone gives you the wrong input, then it breaks, right? But if you ask for a double and they type in a double, it works. If you ask for a string and you type in a string, it works. If you ask for a double and they type in a string, it breaks. Okay? Get line though only works with what? Strings. Good news though, whatever the user types on the console can be interpreted as a what? As a string. So when we get into like error handling and input handling, you really want to pull everything in as a string first. Okay, you pull it in as a string because for sure you'll get the input and then you have to convert that string to what it actually is supposed to be. Does that make sense a little bit? All right. Now getLine works differently from CN because CN pulls until whitespace, ignores leaving whitespace, right? GetLine pulls the entire line that's in the buffer, right? Meaning whatever's in the buffer, whatever's left over until a new line character, that's what it pulls. And in this case, it puts it into a variable called line. Does it have to be named line?
No.
No. Is that a nice thing for it to be named, probably? Because you're getting a line? Yes. Right? Might not be that. Right, but if you pull it in a name, maybe then it's getLine CN common name. Right? Pulls up until the new line character. Right? Notice though, it throws away the new line character. So whereas CN leaves that trailing white space, getLine throws away that trailing white space. Right? Another cool thing that getLine does is if you have to parse a lot of data, meaning that you have a bunch of data that's comma separated, tab separated, separated by semicolons, right? We might want to only pull until write each of those chunks down. And getLine allows you to say, instead of stopping at the new line character, I can also stop at any other character that I want, right? So this isn't, it says getLine, but really it's not getLine, it's get until you get a what? A question mark, okay? Just like before, it goes up to the question mark character, and then it discards the question mark character, okay? So you won't pull the question mark in, it will read until the question mark, right? Throw the question mark away, whatever is left in the buffer is still in the buffer. Does that make sense? Questions?
Yeah. Can you do multiple things like question mark and periods and?
No, so you would have to alternate. If you knew, right, you'd have to know what your data looks like in order to get it. So a single character. But you could do a get line like that, and then the next line of your code could be get line within. Okay, so CN and get line do different things with whitespace. What does CN do? Ignores leading whitespace, leaves trailing whitespace, right? GetLine grabs everything until you hit a what? New line character, and what does it do with that new line character?
Throws it away.
Throws it away, okay? So the buffer ends up looking different depending on if you use GetLine or if you use CN. And really when I say CN, right, because if you look at this, GetLine also uses what? CN. Right? So when I'm saying CN, I really mean the extraction operation, meaning the two greater than symbols. Yeah, right? Whichever way they go, one way or the other. If they're the wrong way, you just flip them over. You're good to go. Right? So really we're saying the extraction operation, right, with our two greater than symbols, or some other operation with a function like that. Now this causes problems. All right? So here we go. We have 42 hello hitchhiker in my buffer, right? Here's my code, right? Create some variables, right? Get some data, go from there. Let's look at what happens. Now I have hello hitchhiker, right? On different lines, right? But really there's no lines in a buffer, right? So really what do I have? I have 42, and then I have a what?
A new line.
Right, good. So the new line character, and then hello space hitchhiker. Are there two H's in hitchhiker? Right, a period, and then probably because I got input from somewhere, right, there's probably actually another new line character. that make sense so far? Right, I have two variables, in and what, line? Line's a pretty good name for a variable, in's a terrible name for a variable. Agreed? Okay. So, first thing, Cn, right? I told you they were greater than symbols. Cn, the extraction operator, that's what this is called, right? And in. This says what? Get from the console, from the user, right? Data up to a whitespace. So up to whitespace. Okay. So it ignores leading whitespace. What does it do with trailing whitespace?
It'll stop
It'll stop there, right? And so what's going to go inside end to end?
all the way up to hello.
Right, all the way up to the new line character, because that's where it's going to stop.
Oh,
right?
yeah.
So 42, everybody go with that? So it takes those two characters, and because it's special, it's the extraction operation, it knows that 42, two characters, can be converted to an integer and put it, right? So there's magic happening there. Right? That's what's so good about the extraction operator, is that it can convert to any type. So n gets the value of what?
42.
42. Now, once again, Cn says what? Ignore leading whitespace, stop at what? Trailing whitespace. What does it do to that trailing whitespace?
Just leaves it in the buffer.
Leaves it in the buffer. So what goes out of the buffer?
42.
Everybody go with that? Okay. What does getLine do? Because notice the next line is what? GetLine. Right? GetLine says read from some stream, in this case Cn, right? Same buffer. Right? How does it read? What does it do? Takes everything up to the new line character in the buffer, and then what does it do with the new line character?
Gets rid of it.
Gets rid of it, right? Throws it away. Okay. So this is everything that's before whitespace and or a new line character in my buffer. Agreed? Which is actually nothing. So what goes in a line? Nothing, right? The empty string, if that's what we want to call nothing. Okay, and then what does it do with the new line character?
Gets rid of it.
Gets rid of it. And that's exactly what we wanted our program to do, right?
Mm-hmm.
Well, that's exactly what the program did, right? What do I probably want to be in line? Hello, hitchhiker, right? But everyone see, when you intermix Cn and getLine, you have problems because they both treat whitespace differently. Isn't that so exciting, right? They did it so that I could like give a lecture about that, right? And try to not confuse us. Yeah. So that's really annoying. Agreed? So let's look at ways where I could try to fix that, right? Get rid of that new line character. Right? Someone was asking, right, can I get rid of characters in the buffer, right? Well, we can. And there's a function to do it, and that's called ignore. Ignore is a member function, meaning it has a dot before it. So you put it on the stream. So if your stream is Cn, it would be Cn dot ignore. Right? If you had some other stream, it would be that stream dot ignore. So after you call Cn, because you had that right new line character hanging out there, we want to get rid of it. Okay? And we get rid of it via the ignore function. Right? Now ignore is a little weird. Ignore takes as input, right, a number and then a character. Okay? This says ignore 1,000 characters or up to the new line character. Okay? And we give it a bigger number, and you'll see in some examples later that there is a number that we can, right, just put in there, words that mean a large number. But basically, it could have been that it was 42 and then a tab and then some spaces, right? And then the new line character. And I really want to get rid of all of that stuff, because remember, Cn ends at the first white space that it gets to. So the 1,000 basically says there's not going to be more than 1,000 right, white space characters to get rid of, right? Really, I don't really care about the 1,000. What do I care about?
The inline.
The inline, right? So this says get rid of the new line character, right? So if I had an ignore, right, 42 is going to go in just like before, but before I do a get line, I say ignore 1,000 comma new line character. Right, so it's going to get rid of 1,000 characters or until it hits the what?
The new line.
The new line character. So it goes up, there's a new line, and it stops. Right? So you're actually removing things from a buffer. All right. Now, when I do a get line get line says read until a what? A new line character. And so all of this goes where?
In the string.
Right? And what happens to the new line character?
Gets deleted.
Gets deleted, right? Because that's what get line does. And now things are looking good. Does that make sense a little bit? Questions on input? All right, there's some other things we can do with the buffer. So we have a function called get, right? Get gets a single character, so it always pulls in characters, but you get a single character back. Right? So cn.get returns a character variable from the buffer, right, and stores it in that. Now, once again, if you don't have a buffer, right, that's when you get prompted on the command line to type something in and hit enter. Does that make sense? But if I type 10 characters and hit enter, I've now put 10 characters in the buffer, and get only gets how many characters? 1, right? And so it's not going to prompt me for more characters until the buffer is empty. Does that make sense? Right? Right. So next is to add the next value of the character in the buffer. Now, there's also a function called peek. Okay? Next gets that character and pulls it out of the buffer. Peek just looks at the next character in the buffer. Right? So next would take H out of the buffer. Right? And you would get it and you can do something with it. Right? Peek says E is the next value in the buffer. It leaves it in the buffer, but it brings back that value. Right? So you can do checks on it or something like that without removing what's already in there. Right? Because you're just you're not getting it, you're just peeking at it, right? Just looking. Does that make sense? So you can do loops to get all characters until a certain character. Right? Eventually I titled this lecture Advanced Input, but we're gonna have like an advanced input lecture later on, so that'll be fun for us. But there's these things that basically check to make sure everything's all good. All right, so I'm going to loop. Remember we learned loops last class? So while cn.good is true, and what? The next thing that I got is not the new line character. All right, so that'll pull up to a new line character, right? And it will get the next character. If everything's still good, I'm going to output that next character. And it's going to keep looping while everything's good, and I haven't hit the new line character. It's basically doing the exact same thing as get line, but getting a character right there.
What does good look like?
So there's state associated with every input stream and every output stream, and it just checks the state to make sure everything's good. Okay. When does cn go bad? Right, the most obvious one is when you ask for a integer and you type in a word. Okay, cn's no longer good, cn's bad. And once cn goes bad, you can't use it until you fix it. Okay. That's for our advanced input lecture, right? Which we're not doing today. But you guys are all pros now, right? So everyone see my buffer in the top right? 1, a new line character, test, a new line character. Right? I have a couple variables, right? In and line. Right? So at the end of this, what's the value of n? Say it louder. My ears don't work. 1, does 1 sound right? Right? Because cn's going to look in the buffer, and there's already stuff in the buffer, so it's not going to prompt for anything. Right? And it'll take the first thing 1 and put it into n. What's left in the buffer?
New line.
New line
test.
character still in there, test, and another new line character. So what does get line pull in?
Nothing.
Nothing. Good. I didn't pull anything. How do I fix it? I use that ignore, right? So now n has 1. I throw out the new line character. And now line has what? Yes. Ooh, here we go. So there's next, right? The first time I call cn.get, what's the value of next? You remember what get does?
You're just constantly pulling T out?
Well, peek would constantly pull T out. Get gets the character and moves on to the next thing in the buffer.
Oh, okay.
So the first time you get what? T.
T.
And let's make the distinction because C++ does that, it's a capital T, which is different from a lowercase t. Right? And then cn.get the next time, next gets what? E, right? And then we get S. All those are lowercase. Right? And then the T and the new line character are still in the what? The buffer. Right? Remember, \n, while it looks like 2 characters on the screen, is really how many characters?
One.
One, right? Escape sequences are always one character, even though they're backslash something. Does that make sense? Questions there? Oh, now what's going to happen? While everything's good, and the next thing doesn't equal the new line character, we're going to get a character, and if everything's still good, we're going to output that character. Okay, so the question is, what gets outputted?
Test.
Test with the new line character or without?
Got it.
Without, right? Because once I pulled in the new line character, actually, let's look at this a little bit more closely. Right? So I pull in T, right here, T, everything's good, so I output a T, right? Everything's good, and we're not the new line character, so I pull in an E, right? But at the end, next we'll pull in a what? A new line character. So next becomes a new line character. Everything's still good, so what do I output? A new line character.
Oh.
And then I go back, and I say, while, right, I'm not the new line character. So then my loop breaks. So I actually get test and a new line. So I have to pull it in first before I did it, right? If that was a peak in the while statement, then, right, we wanted to pull in the new line. But in this example, we pulled it. Sound good? Oh, like this, right? Do we output the new line character this time? No, because we're always looking forward, right? Is the next thing the new line character? Right? So this one does not output the new line character because we're looking forward. We're always looking, right? Is the next thing the new line character? Is it? And once it sees it, we don't go into a loop because that's false, right? So those two are a little bit different, right? One's after we pull it in, one's before we pull it in. Are we good there? Should we see an example, maybe? Possibly. We can make this work. All right. Everything we did is all part of IOStream, right? So we have a couple of using statements, but there's not much there that we need. So how does this look like for, right? Because really, we don't have input streams just built in, right? We have to, or buffers built in, we have to type stuff and hit enter. So let's just see how that interaction is going to work out for us. So we're going to have age and choice. Actually, we don't even need choice. We're just going to do age, and we'll do name. And we'll see how, right, enter your age. Right, seeing your age. Right. Are we good with that? Right.
Your int is not spelled correctly.
And add age. Does that look better?
Yes.
Okay. I'm good with that. Get some more spaces down here. There we go. So we have age and name, we enter our name. That should work fine. Right, and in fact, if we run it, right, 3 pluses, let's do pluses. This is basically the exact same thing you guys do on CodeNB. I just didn't like how it looked on the screen, so I'm doing it locally on my machine. Right? Enter age, we're 1,000 years old. Doesn't that sound great? Right? Everything works. Okay. Now, if we do get line right above it, right? Get line. Actually, let's do this. We say cn name. All right, and we can say out. Right? Name. You are age years old. I know how to type, I swear. I can do it. Right, enter my age, we're 1,000. Right, and my name is Catherine. Right. And notice it only says what?
Luke.
Luke, you are 1,000 years old. With no spacing, because I forgot. We should do a comma. Right. And that happened because what? CN only pulls to what?
The white space.
The white space, right? And it leaves the white space in there. So instead, we could do a get line, right? CN, right, and a name. Now it should get the entire line, right? Say yes. What happened? Program ended. Did I get to type my name in?
No.
No, right? Because when I typed 100, I really typed 100 and a what? A new line character, so that all went into the buffer. My CN statement pulled in 100, stopped at the trailing white space. So the 100 came in into age. Then I did a get line, and it said, oh, there's something in the buffer to a new line character. So do I need to ask the user for more input? No. So I didn't. Right? I just used what was in the buffer, which was what? Nothing. And then my program ended. Does that make sense? It's kind of unsettling as a user. You're like, what? Never let me type my name in. Right? So how do I fix? Anyone remember?
Ignore.
Ignore, right? So between these two things, you would do cn.ignore. Right? And the lazy way is just to say 1,000. And you can ignore to anything, right? You can ignore, right? I don't like T's. I'm going to ignore all T's that happen.
So the 1,000, if you were to put 10, but it only count 10 spaces. And
10 would mean that if it didn't hit a new line character by the time it hit 10 characters, then it would stop.
it would stop ignoring.
It would stop ignoring it. Yeah. So we want to give it more than what we think a new line character could possibly be on. So it's not going to go 1,000, it's only going to go as many as it needs.
You just, basically 1,000 just says you're covering the entirety of.
All right, and now we can do that, and I'm going to type in my name. And there we go. Make sense a little bit? Right? So we don't want errors, agreed? All right, so if you're going to mix the two, and you might, because sometimes you want to get, integers, double strings, right? And CN with the extraction operation works really good with that. Sometimes you want to get like strings of characters on a whole line. And get line works well for that. So if you're going to switch between the two, ignore issue. Sound good? Should we talk about string streams a little bit? Right? So CN, CL, they're both streams, right? And they're all linked up to the console, right? So that's why we get to interact with them, right? String stream is a stream that is not linked to a console. So it has its own buffer, it works the exact same as what we saw, but it's going out to this magical place called a string stream, right? I think of it as like a file, right? But the file doesn't exist in the file system, right? It's this place, you can write whatever characters you want to that file, and at any time you can pull all the characters back as a string. So it's really useful, right? When you want to create strings that are intermixed, or really useful if you want to extract data, right, that came in as a string. Okay? Because right now, if I have a string, right, if I have a string like this, now let's look at this example. If my string is 42, right, so in my code I had string s equals 42, right, how do I make int x equal s? Right, how do I do that?
Convert it.
How do I convert it?
String stream.
I have to use a string stream, right? In C++, I have to use a string stream in order to switch up. That's the only really big way that I have of doing that. There's some other functions like, right, A to I and stuff like that, but those are old school. They don't work. They work, but we're not going to use them. Right, so string stream is really the best way I have of converting from, right, some value to a string or from a string to some value. Does that make sense a little bit? Right? The need for them, right? But it works the same as C and CL. It has its own include S string for what? String stream, right? IO string, S string. Eventually we'll do files. That's called F string. Right? We tried naming them nicely. And then you need to declare it. Okay, so when you include IO stream, C and CL, declare it automatically. Yay, right? Declare it automatically. String streams aren't. Okay? So string streams its type. Right? SS is its what? Name. Do I have to call it SS? No, I call it anything that I want. And later on you'll see that sometimes I call it like S out, because I want to use it like what? C out. And sometimes I'll call it SIN, right? SN to look like what? C. Try to name it something useful for us. But once declared, because it is a stream, you use like C in and C out. One weird thing about string stream it is an input and output stream. So CNN only does input. Cout only does what? Output. Streams do what? Input and output. So you can use the extraction operation with them, or you can use the insertion operator with them, because they do both. So you can output, right? What's the beauty? You can output a string to it, but you can also output a what? An integer to it, or a double, or a character, or whatever, right? Just like when you console output, right? Can we output strings to the console? Yeah. Can we output integers to the console? Yeah, right? It all works. All right, so it all works for us in order to do that. Input, it's the extraction operation, right? So it says whatever's in that buffer, right? Whatever's in that string stream, pull something out to Whitespace and convert it to a string, right? This says whatever's in the buffer, pull it into your program up to Whitespace and treat it as if it was a what? An integer, right? Does that make sense? Right? Pull it, treat it like it's a double. So even though it's a string, right, you can pull it back as a different type, so long as it, right, matches with that type of stuff.
What's the advantage of this over like static cast?
Well, you can't static cast from like strings to ints. So static cast works great to go like ints to doubles, ints to chars, but you can't go strings to. So this is bridging the gap of multiple characters. For a lot of times, it's useful to get everything you outputted as a string, and so to do that, you use a function called .str. And so str converts whatever you outputted to your string stream, it converts it to a string. And then you can store it. You're going to get used to a lot of times, I'm going to return stuff as strings, right? So your labs are going to say, please return, right, this as a string. Well, to build that string, you probably want to use a string, and then just return ss.str, right? Return everything that you would have outputted to the console to a string. Why would I rather have it back as a string as opposed to output it to the console? It could interfere with stuff, yeah, right? It might make output not look nice, right? What am I testing your labs with? Right? With what? Every lab you run, what does it say? Pass, failed, right? It's this kind of unit test thing, right? Well, if you output it to the console, then I have to like grab that output from the console and like bring it back into my program and like test to see if you did it right? So it's a lot more modular if you return things as strings, because cout always outputs to where? The console. Where does strings output to? That's a weird question. Like, strings don't output. Where can you output strings to? Can you output a string to a console? If you have it as a string variable, could I just cout s? Would that work? Yeah, right? But later on, right, we're going to find out that you can output the files, right? You can move that data from function to function. So it's a lot more modular if you can return things as strings. And then if you decide you want to output it as to the console, you can. But if you cout to the console, you can't then also have it as a string and move it around. Right? So it's a lot better for us to store things as strings and move those around as opposed to outputting to the console. You can also start a string with a current string. So you can also say, right, create your string stream and then paren say, I want it to start with this data. We do that sometimes. A lot of times they start empty and we add data. But you can do it either way. Notice this time I didn't call it SS, I called it what? Read string. Let's look at a string stream example. So it does have its own include. Right, so let's bring that in. So we can include IO string, we can include string, and now we include, you remember what it was? S string. Right. And then we've been using so long, std : string. One of the longest things that we write. All right, let's do some fun things with my string stream. So let's create some variables. We have age, and then we're in the new age, so we're going to be new age. And we'll see where that comes from. string, name, age, and a name. And then to create a string stream, I just say string stream, right? And I call it SS, short for what? String stream, right? Try not to be too crazy or too difficult here. So let's look at what we can do here. Let's go back to our old example, right? Please enter your name or your age, right? CN age, CN.ignore. So now I'm going to pull in, right, from get line. So we're going to ignore the new line character, and then please enter your full name. Notice how my programs are very nice. Right, your programs usually aren't. They're pretty snarky. Mine's right. Please, if you would be so kind as to give me your full name. And then just what we did before, get line, and we'll say we're going to get it from CN, and we'll get it. And then I can see out, right? Hello, right? Your name, right, comma, you are, right? Age, years old. And we're good so far. This is basically what we just did before, right? Ask the user via the console for their age, get their age. Ignore any white space. Ask the user for the full name, get an age, or get their full name from the get line, right? And then output. You're like, this should be easy, right? This is not. Right, are we good there? Right, same stuff. Are we good? Now, let's look at this. Not only did I create a cout, what else did I create? Remember, see up here on line 14, I created a what?
String stream.
Now, it's a stream, so it actually looks a lot like, so I'm going to just literally duplicate the line. I'm going to SS it. Okay. Cout is an output stream. SS is also an output stream. It's an input stream as well, but it's an output stream. So these two operations work. Okay, cout though is going to go to where?
Console.
The console, and SS is going to go to where?
String stream.
Right, a string stream, a magical place that we cannot visit. See if I have my fingers working just at the right speed. All right. Now, I saw the console output. Did I see any string stream output?
No.
No, because string stream doesn't go to console. It goes to, right, the magical string stream link. Okay, so what can I do with it, though? Let's look at what I could do with it. All right, so I do my string stream, and then I could do something like name age, which was a variable I created, right? It's a string. So name age equals ss.str. Now, name age is a string, so if I output in name age, is that going to output anything?
Yeah.
Yeah, right? In fact, I'll output what? Hello, right? You are whatever. Right, so let's see how that works. So I get one output via cout. My other output comes from cout as well, but I put it where? I put it to a string stream first and then pulled all that data back as a string. Like, that seems like a lot of extra work for what? Well, really for nothing at the moment, right? So let's see where this could be useful. In fact, I'll just delete this line.
So you can't just do the SS string right where name age is, yes.
I know I could. So I could have just done cout, yeah, ss.str right here. I just decided to store it. So my rule of thumb is that if you're only going to output it one time, just output it. you're going to use it multiple times, then it might be better to store it. Because that ss.str is a function, so there's right a little bit of time associated with that, how long it takes. And if I'm going to use it 50 times, I don't want to keep doing that operation over and over again. So I'll store it, basically cache it. And we'll be good there. Okay, so what else can I do? I'm going to do this string. I'm going to create another string, right? SS with var, right? And I'm going to put into it name age, right? That's basically the same as saying string SS with var, and then SS with var, 2 less than symbols, name age, right? I'm just trying to get some data, in this case, that, right? Hello, Luke, you are, whatever, right? I'm trying to get that string inside of my string. So it's now started with that, okay? So this string has that with us. So let's talk about what I'm going to write here. Because it's a lot. Because now all of a sudden, things got a lot more complicated. Okay, so string that I called with a really long thing, SS with var, right? Started out with that whole, right, string that we created. And that string that we created was something like what? Hello name, right? You are, right, 100 years old. Very good. That's what's in the string. That's what's in the SS with var. Okay. It's not a string. It's a string. Okay. So I need to use anything that I could use with a string, right? Which we learned earlier today, right? With that. So let's look at what this is doing. It kind of reads nice, but it kind of doesn't. Okay. So while something's not a digit, so we always need to start from the inside of parens and work our way out, right? What does .peek do?
Looks at the next.
Looks at the next character in a string. So .peek, the very first time, is going to look at what? The H, okay? And it looks at it, but really, for our purposes, it returns a character to me, okay? What does it return to me? Character H. Remember that? What it doesn't do is it doesn't move me to the E, right? .get would move me to the E. Peek says, right, really get that character, but don't move me in the buffer farther, okay? So, SS with var.peek, those parens, evaluates to a what? An H. Remember good so far? Okay, so H is what that function evaluates to, right? Well, that function happens to be inside of another what? Function. Okay, and that function is what? Is digit. Okay, we learned is digit last week. What does is digit check for? Whether it's a digit or not, right? So it returns true if it is a digit and false if it's what? Not a digit. Is H a digit? No. So what does is digit return? False. Okay, but what does it not do to a false? Makes it true. Agreed? So the first time this loops, that while loop, the whole thing, what does it evaluate to? True. So do I loop? Yes. And what do I do inside that loop? I what? Ignore how many characters? 1. So what goes away in my buffer? H. So H goes away. I gotta go back to the check again, right? Which means I have to go back to the peek. Right? Peek's at the E. Is E a digit? No. But we not a no when we get a yes. So we loop again. And what do I get rid of? The E. Right? Then I get rid of the L. And what do I get rid of all the way to? The 1, right? Because the space is not a digit. So I loop again. I just peek at the 1, right? So really I'm here. Right? I peek at the 1 digit. Right? Well, the 1 digit is a digit, so that's true. I'm not a true, and I get false, and so how does my loop? It ends. And so really, what did my loop do? It got rid of all characters until I hit a what?
A digit.
A digit.
So a very complicated way to clean up the buffer.
Right. Right? Because my next operation is going to be this. SS with var. And then we're going to pull into it, right, my new age.
Oh.
Okay? What does the extraction operation say to do? Pull in from a buffer. Here's my buffer, right? Ignore leading white space and stop at trailing white space. Okay? So what does it pull in?
100 years old.
100. Not the years old, just the
Just
100,
100.
right? Because there's spaces, so we're going to stop at each of those, right? Technically, there's a new line character. So it's going to pull in that 100, right, into my variable. Now remember, Cin would break if what? If this, what was in the buffer, was not a number that it could convert. So I made sure that it was a number that I could convert by throwing away all characters until I hit a number character. All right, so basically I made sure that the extraction operation was going to work by throwing away all characters until I get a character that I know is a number, right, is digit. Does that make sense a little bit? Right, and so then what comes into new age?
100.
100, right, in this example, 100. Right, and so if I see out, right, the new age, I'm expecting it to be what? 100. I'll answer that question for you. Let's see if it works. Right, we're 100. Our name is now name. Right, it says, hello name, you are 100 years old. Right, and my age extracted was what? 100. And it worked, right? Because I got rid of all the characters until I hit a digit. Okay? So you see this character function we learned last class work well with streams, because streams are made up of characters, and we use character functions on characters. Questions there?
So it has an internal Ethernet?
Yeah, so there's, behind the scenes, basically there's a pointer that knows where in the buffer you are. And so when you call get, it'll move you forward 1. Peek does not move it forward. Ignore will move you forward 1, or however much you say that you want to move it forward.
So what would you have done to get the years old and the extraction point?
Ooh, I could have done like a get line next if I wanted to. Right, because at this point, right, in my example, right, we extracted the 100. And so this buffer is actually, that's where we're at. So if I did a dot get, I'd get a single, or I'd get space. So then whatever I would write, if I want to get everything, I could use get line. If I wanted to get the next word, I could use Cin, or the extraction operator.
But you have to ignore one white space.
Well, if I just use the extraction operation, it ignores leaving white space. So it would pull in just this. I know, it's a little confusing. That's why we're doing some practice work. Other questions? This is why a lot of other languages do it differently, because it's not as complicated. That's right. Once you can drive the stick shift, you can do whatever you need to do, right? Like, oh, this is not nearly as hard as C++. We'll be good. All right. I'm going to introduce functions. I'll get a little into this lecture, but I'm not going to get all the way to the end because we're going to run out of time. So when you think of functions, right, there's really 2 types of functions that we're going to really talk about, okay? There's functions that return a value and functions that do not return a value. And what we really mean is there's functions that produce something, and there's functions that do something but don't produce something. Okay, so there's functions where, like, I put stuff into it, I get something out of it. Okay? I mean, even like the Goldilocks one you guys wrote for your last lab, right? You put into it, or really I put into it, right? An item and a number, and what I got out of it was a string that said either the porridge is too hot or what have you, right? Or functions like square root, right? Square root is a function built in where you can put it in a 9, and what you get out of it is what? 3. Right? These are functions that return a value, meaning they produce something that you can now use. Okay? That's useful. right? Functions that produce a value means that we can put values in, they come out, and we can now use that value other places, okay? Functions that do not return a value do some operation, but they don't necessarily produce a value. They do an operation, but they don't necessarily produce a value. Things like what we just saw, dot ignore. Dot ignore ignores characters in the buffer. Does it produce a value? No, it just does an operation. So both are useful, right? Dot get, it gets a value, right? It produces a value from the buffer. Dot ignore does not produce a value, but they're both very useful functions. So there's functions that produce a value, right? And I'm calling that return a value, or there's functions that do not. Right? In C++, functions that do not return a value, we say they are what type of function?
Void. Void, right?
Void, right? Void meaning the absence of something, right? They don't return a value. Now, functions take input through parameters, right? And this is something that we're still trying to change a little bit, okay? Input does not mean input from a user at the console, okay? Input can come from lots of places. Okay, functions take input via parameters, right? They take data in via their parameters, not via CN. Right? I know some of us have been struggling with that a little bit, like in the labs. You're like, great, it says that it takes in an item and it takes in a number for Goldilocks. So I'm going to CN an item and I'm going to CN a number. Right? Remember, parameters, those things that are in the parentheses of your functions, are the input for your functions. So the data's coming in, right? And in all of your basically in all of your labs, I'm providing the input, right? So I've hard-coded input for all your functions, right? And then your job is to take that input and do something with it, right? They can be used inside the function definition, right? So you create them, right? And now you use them in your function. You don't have to recreate the variables, they now exist. We put them in the parentheses as parameters, they exist, right? What gets passed into parameters? Do you remember the name of those things? Oh, well, that's dumb. I clicked too far. They're called arguments, right? So arguments are the data that gets passed into parameters. Okay, arguments are the data that gets passed into parameters. And they can be literal values. So like literally you could pass in hello world in double quotes or the number 5. Okay, so literal values. They can be variables, right? You can pass in X, Y, and Z because X, Y, and Z hold what? Literal values. They can be expressions. Oh crap, what the crap are expressions? What do expressions do? They always become a single value, okay? So expressions are combinations of things like function calls, operators like plus, minus, that kind of stuff, variables, literals, right? But that whole operation will always become what? A single value, right? Boolean expressions always evaluate to what? True or false, right? Because it's an expression, it evaluates to a single value. 5 plus 5 times 10 evaluates to a single value. It's a what? Expression. Does that make sense? So expressions evaluate to a single value, which is why you can, right, they can be an argument because that value will be computed and that will be passed into a function. I didn't put it on there, but they can be function calls as well, right? You can have crazy things like, right, the square root of 9 plus x, right, all, right, powed to the 3, right? That right there is an expression. A complicated one, right, but an expression, right? Because it becomes what? A single value, right? We take the square root of 9, which is 3, we add whatever the value to x is to it. We take that, we pass that into the pow function, so whatever that value is, we're going to cube it, right? Which will produce a single value at the end. Okay, so expressions always become a single value. So we said they return a value, they perform a function, not return a value, right? We call those void functions, good. And remember, in C++, the first word in my function declaration is the return type. So we have to say, yes, this function produces a value, and its value is a int, or its value is a double, or its value is a string, although we won't do that, right, technically. So at the beginning of our file, we will create, right, what we call function declarations, or you'll also hear me call them function prototypes, because in C++ we call them both. So you should be familiar with, some people call them prototypes, some people call them declarations. Right, we're basically saying, right, we're declaring I have a function, and this is what it looks like. There's a lot of really good info in a function prototype. First word is the what?
The return type?
Return type. So this says that this function will produce a what?
A double?
A double. And functions always produce how many values?
1.
You always get one value out of a function. So you're not going to get 2, 3, 4, or 5. You get one value out of functions. Right? The name of the function is what? Total cost. So if I was going to use this function, I would have to call it what? Total cost. Just like the name of this function is pow. And the name of this function is square root. Right? These are my comic book powers. I like pow. Pow's a good function. There's no BAM function though. So. Oh, my battery's running low. That means I've been talking way too long. We'll see if we make it. Now we're going to live on the edge a little bit. So there's the name of my function, total cost. What does it produce?
Double.
A double. What does it take for input?
And some doubles?
Well, an int and a double, right? 2 things, right? Parameter 1, comma what? Parameter 2. And it tells you that the first parameter is an integer, and the second parameter is a what? A double. So at the very least, you know that with this function, right? If I was going to write some code with it to use it, right? Not to write it, but to use it, I would have to say total cost, right? I would have to pass in an integer, right? I would have to pass in a double, right? And all that would produce a what?
A double.
A double, right? I don't have any documentation, so I have no idea what it would produce, right? But that's what it's going to produce, right? It's going to take in an integer, right? A double, and it's going to produce a what? A double. Everybody with that concept? We should be able to look at a function declaration and figure out, right, the mechanics of it. Once again, we have no idea what total cost does, right? But we should, any function, be able to look at it and be like, okay, it produces a double, right? Its name is total cost, and in this case, it has 2 inputs, an integer and a double. We good with that concept? Right? Now the hard thing for us is that we have to like write the functions, and we also have to what? Use the functions, right? Which is actually 2 totally different operations, right? Writing the function is much different from actually using the function. It's nice when you only have to do one or the other. Let's go forward. And then below main, so this goes above main, it's a declaration. Below main, we write the definition, which is the header and the body, which basically is this whole thing again, but with curly braces instead of a semicolon. And inside of there, we actually write what the function does. So that's the function header, right? And then you get the body in there. Right, and the body is basically like main, right, but self-contained. So inside of there, you can create more variables. You can use your inputs, so the parameters, right? And then at the end, if it returns a value, you need to what? Return a value. Right, some of us, I think on the last lab, we did the work to create values, but then we forgot to return them at the end. Right, you can create the values, that's great, but how you get the data out? Return. Right? Or in my example, you need to return what? Something, right? Only if you said that it produces a value. It's void. Do we need returns? No.
You have to, so like it's returning a double, if both your inputs are mixed, you have to turn it to a double before you return it.
Yeah. It won't. So if you return a double and you take in 2 ints,
You give it, like you say, return an int, it'll give you.
it'll type course for you. So it will auto convert.
Okay.
Yeah. So if you say if you say the function returns a double and you return in 1, it's really going to return 1.0. Look, I played with fire and now it's done. I was hoping for like sometimes it's like your battery is critically out. Now we're at the end. Maybe it knew that we were getting close. We'll see if it comes back. Well, my notes, I might just talk about functions for forever, but I might not get anywhere.
Is return 0.
Okay, so great question. In main, right, we always return what? 0. But when we look at main, main's coded like this. Correct? Agree with that? Which is a function, agreed? Right, what's the name of my function? Main. Does it take any input? Not yet. Guess what? We're gonna learn how to do that. Not today, but we're gonna put some things in print. What does it produce? An integer. Which means that at the end of main, you should return a what?
Integer.
An integer. And we always return what?
0.
0. 0 for main means everything's A-okay. So we're starting to do some things in the console, right? Well, the console expects, or the console can actually read output from a program, how it returned. And so 0 meaning, right, everything was fine. Anything but 0 would be an error code. So if you return 1 or you return, right, 2000, that could correspond to some error code. So that's why we always return 0. Because our programs always what? Work, right? There you go. Did you just connect that? Isn't that so nice?
Took the opportunity, sorry.
Right, take the opportunity.
I was thinking I
There's
could-
all stuff. This is what we're doing today, right? This is good. So now I know how far we need to go. Don't show everyone their code now.
There's nothing
That's right. Then you put some codes on here. There we go. Don't be taking over my screen. You're just wasting everyone's time. I think we're about to do a function example, right?
Yes.
Yeah, that's exactly what we're going to do. We'll figure it out. I'm not going to waste our time writing everything, so I'm just going to paste it in.
It's cheating.
I know, right? It's so nice when you have the answers. Okay, let's talk about this. Here's main. Above main, I have my function prototype or a function declaration, right? It is a function called total cost that takes in an int and a double, just like we saw. It returns a double. And up here, right, above the function, I have a comment saying what it does. Total cost computes the total cost, right, based on a price and quantity of an item. Right? You'll notice in the lab ones, I also have those at params, because that helps you figure out, okay, at param, what is int quantity? Right? At param, what's double price? And then at return, what is it returning? Right? But in this case, quantity and price, right? I give it a quantity and a price, and it computes, right, the total cost, right? It returns the double. So it's actually named pretty well, which is surprising for me. Right? And then below main, right? I have a simple line that just says return price times quantity, right? The function takes in price and quantity, and I return the price times the quantity. Isn't that an exciting function? Like I got to just multiply it anyway, right? But that's one single unit of work that my function is doing. It takes 2 inputs in, produces 1 output, right? And anytime I call this function, right, that output will be produced for me. And so most of the time we call that output in main. Right, so in main is where I get data from the user, right? Enter how many items you purchased, enter the price. So you'll see once again, my function does not take input from the console, right? The thing that uses my function takes input from the console. I'm gonna see that distinction, right? Because now total cost isn't just used for console input. I can use it for anything, right? Get the data from anywhere, right? In this case, I wanna get the data from the console, so I do. So my bill is calling the function with the number and the price, right? We'll talk about the magic formula eventually, but the magic formula allows me to get precision. So like when I output things, right, that look like money, I want precision of 2. So these are just 2 lines you can write to do that, right? You could change that precision if you want, but then, right, I'm outputting stuff with dollar signs and then what I want. So I'm using these functions, right, in order to get what I want.
So you had something declared function above in main
And below. So the thing above, you'll notice the big difference is the thing above has a semicolon. That's declaring what it looks like. And then below main, right, there's no semicolon. That's actually the function. So you'll see that some people write the whole thing above, but we don't like it up there. But because everything in code's top down, if I want to use the function in main, and I write the function below main, it has no idea about that function. So the declaration says, hey, it exists, right? And then the compiler does the work to get everything to sync up. So it'd just be like, right, I can't use X until I declare it. So in this case, I can't use function total cost until I must be talking too long, everyone's getting phone calls. You're supposed to be at a lecture by now. Right? What's going on? My professor's just rambling over and over and over again. Okay, I'm going to see if that's enough that we need for our labs. Let me pull up our lab.
The lab looks like it just uses a lot of string
Yeah, I think
strings.
that's true. There we go. All right, lab 4. Are you guys excited about lab 4?
So excited, I'm dying.
Yeah, I tried to put my code up there and we could all work on it together. Ooh, look at all the function prototypes we got to do today, right?
Oh,
So we have just 5. I think you guys had 6 the other day. Right? So 5 doesn't
it's
sound
too
so
many.
bad. Right? So make string, and then we're going to do a bunch of conversion things. How am I going to convert data, right, from strings to something, right? So string to char, string to int, string to double, string to bool, right? If you actually look at the lab, I wrote one of those already. So there's 5 there, but I wrote one for you. So there's really only 4. All right. So let's talk about it. What does make string do? Right? Return a string comprised of a label followed by a space followed by a separator character, blah blah blah. But I give you some examples, right? What it should look like. Pretty similar. Remember we did char to ASCII the other lab? We're going to create a string based on a character and also like a converted integer value. Here you're going to make a string based on, right, a label, a value, and a separator, right? But because you're making a string and one's a string, but one's a double, you're going to have to use a what? String. Right? Which, if you look at line 59, what did I say? I say at uses what? String. Remember, the comments are actually quite useful if you read that. They're there for you, right? And for me, so you don't ask me dumb questions.
So you're trying to help us?
I'm trying to help you. I even tell you what it would look like. Now, where do these values come from?
Somewhere.
Somewhere. That is a great answer.
It may.
They come from somewhere, right? And so when you write that function, remember, those values are not coming from constants, but you're not asking for them. They're just going to come in, right? Basically, you said that my function takes a string, a double, and a char. And right, really, I said, but right, you're the one writing the function. And so those values will just come in from somewhere, and it's your job inside of the curly braces to do something with those values. Okay? If it helps you, right, you can think of, well, okay, this is temperature, this is 41.7, and that is a colon, right? If that helps you, right, to help write the function, then think of actual values. But remember, those values can be any values, right? This could be any string, which a string is 0 to infinite number of characters, right? This could be any double value, right? And this could be any of our characters, right? They could be any of those things. So your goal is to write a function that does whatever it asks for. Make sense a little bit? Mm-hmm. And then a function that is useful for you, like string to char, all right, takes in a string and it's going to convert it to a character. Okay? Strings can have how many characters in them? No, strings. Strings can have how many characters in them? 0 to many, and characters have how many in them? 1. So in order to convert from a string to a character, you have to make sure that string has a length of what?
1.
1. Because if it has a length of 0 or a length greater than 1, it's not a character. It's characters, right? But you're supposed to convert it to a character. Does that make sense? And so this tells you what to do, right? It says, oh, if it's not, right? So you return the first character of the string or the null character when length is 0 or length is greater than 1. So string to char will only convert to a character if it's actually a character, not a string, right? Does that make sense? Right? So you have to have a pretty basic if statement in there to make sure. Right? String to int. Useful when you have an integer inside of a string and you want to get it out. Make sense? Okay. Please note that when I say this function provided as an example, that means that I wrote the function. It works. It passes all the tests. Do you need to rewrite string to int?
No.
No. Okay? But string to int works a heck of a lot like string to double. Okay? Because ints and doubles are numbers, so the way you convert them from strings to numbers kind of work the same way. So I probably use string to int as an example for you to write what? String to double. Okay? Whereas things like characters, right, they have a different relationship with strings, because strings are strings of characters, right? So the way that you convert those is different. Right? Numbers kind of get converted the same. Right? You will see that in here, right, I take some value, right, which is my string, I set up an integer value, and then later on I try to bring in that value, right, and extract it to an integer. Just like before we did SS with var and we extracted the new age, right? So it's kind of doing the same thing, it just has some error stuff that I want to talk about it wrapped around it to make it work. And what's the last one? String to bool, right? Now string to bool is converting a string to a boolean, right? And it's all about, did the user type something that starts with a T, or did the user type something that starts with an F? Okay, and really, because it can only be true or false, really, if they type something with a T, it's true, and if they type anything, then it's going to be false, right? So read that carefully. People forget that because two things return the same thing, they still try to make them their own cases, but there's only two cases. Either they type true, and it's true, or they type false, or they typed anything, and it was false.
That's an if statement, right?
What?
That's an if statement with get peak.
You can look at it, yeah. Although you don't have a string, you just have a string, so I would use like .at. Right, .at 0 will look at the first character, assuming there's at least one character in your string. Remember, .at's not going to work if there's no characters in your string. So I would read those instructions as well. And that's the last one. And then today you can do an interactive test, so you can like type stuff and make sure, right? You're like, oh cool, it's converting, it's not converting. Right? And then you can do the normal unit test and it'll say pass. Questions on any of that? Okay, so next class we got to finish up parameters and overloading, and then I think we're going to do arrays. Yeah. I'll pass around a sign-in sheet too, so make sure that you sign in today, and then I'll just be here to help everyone out. Of course, you guys don't need any help. Right?
Right.
Yeah.
Right, yeah. You're so smart. Thank you.
You said they use a for loop to put the two lower into upper.
Yeah, what you want to do is you want to have a for loop that checks every single character in the string and uppercases it or lowercases it. So in the to upper, you would have a for loop that checks, like if you say the string's name dot at, and then you would say I, and I would start at 0, and then you, in the for loop, it would increase by 1 each time it runs through, so it'll check at point 0, 1, 2, whatever, right? And then you also have to say, as long as the size of the string is not greater than...
I Google with two lower function, two upper function, and trying to model my for loop after that, and it's not really
Okay, let me see, let me look at mine. See, to lower here, what it does is you create an integer in the for loop, right? Which I made unsigned because the string is unsigned. And then you compare I to the inputs, the string is input, you compare it to the size and say, as long as it's less than the size, then add one value to I.
See, I was trying to do something completely different.
You could also use a while or
I
while
was
loop.
kind of using a static cast and put a string in the brackets to try and like get the. Like, here's just look at what I have. It's kind of hard to describe it from memory.
Yeah.
But it's something like completely different.
So the basis of this is you would say at I, which starts at 0, you would say at the very first point of the string, you lowercase it.
Alright.
And you would say input dot at I. You would lowercase the input at spot 0. It would run the function again. It would say, okay, as long as, because now I is 1.
So you're not using like this whole like two lower in the parentheses in your function. You're just working on the like the string input.
Yeah, I didn't make a new string. I just used the one that's coming in.
Alright.
Because the one that's coming in, I can just check it.
I was using like the whole like two lower thing.
Yeah,
Thinking
there's
that would just
there's a
take
2
the-
lower right there.
Oh, I didn't see that.
It lowercases the input at. Input is the string. It lowercases the string at 0.
Alright.
So the first letter, if it's uppercase, it'll lowercase it, and if it's lowercase, it just does nothing.
And where did you find the dot at? Like,
Dot at or.
But did you get that from like in a class example or?
I got that from John.
Oh,
He
okay.
was telling me that at is basically telling you at this spot in the string. So it's like at 0, 1, 2, so on. It'll say at 0, lowercase, at 1, lowercase, at 2. And let's just say you put in a string that's like 7 digits or 7 characters. That's 8. That's 8 spots, right?
Alright.
So I will get to like 8, and it'll say 8 is less than 8. No, so it'll stop, and it'll return input. Because input changes right here, because that's the string,
And
it'll
so
return it.
for
And
two upper, you basically did the same thing with just
you just
two
make it
upper.
2 upper.
Alright.
So the basis of this is you just lowercase every letter in the string by force, or you uppercase every one by force.
What I did in my for loop that ended up causing the problem is I did int I equals 0. I is less than, and then I used the two upper parentheses.
No, you want that inside the for loop.
Yeah.
Because you want to compare the size of the string with I. So so this keeps running until you have no string
I
left.
ended up coming with the problem because coming up with the problem where it didn't like I was comparing an int with a string. So
Yeah, you also want to make this unsigned. Because strings are unsigned, the size of them are unsigned.
Mm.
So you're comparing two unsigned values, so you don't get a warning in the terminal.
Alright.
Because
I wasn't getting a warning, I was getting a note because it didn't like that I was comparing an int to a string.
Yeah, we don't want that.
Drivers for your own testing purposes.
Damn, Daniel.
The idea is that sometimes people get overwhelmed because my test tests all your functions, right, and it does a bunch of stuff, right? And so it's hard to like separate. You're like, okay, I'm gonna go one function. I'm gonna do all the dailies of all the other functions. Right? The driver's like, okay, I wrote one function. I get to do this. So then, yeah, so you.
Unless this works.
Printable? Okay. That should be true, right? So, right, so the big thing to remember is that, C++, well, C++ is not smart, so when you say or key, it's just saying that's true. So which means it's what all three are. So you have to say value doesn't equal T or value doesn't equal T. But this check, right, has to be on both sides of the or. That's the big thing. Did anyone not get the sign-in sheet?
So we won't need sure. Send that value to the beneficiary. Shows the number of funds.
It's just like one.
Jeez.
I'm just gonna one and two.
I'm trying to do this. Hold on. I'm trying to figure it's
Oh, yeah,
it's kind of like there's Debbie and then then there's something similar to this and I'm trying to do
yeah.
It's exactly what you
but
want. Literally, it's so fun.
I don't think I'm missing. I wish I
I would ask you to do this kind of weird like I
This
just
is
did
the
as well.
I'm not sure if this seeing
Oh.
The impact that is the first downside. It's the impact that is the first downside.
Yeah, it is.
Because I can do it straight and I just take something. We're just resting value. That's the value.
So yeah, thanks.
So you could do the main.
Yeah. Yeah, the last few. Oh, you're taking the strings out. Oh, that was good. This first one, if you're just doing it, you have to convert the value to. Oh, you're.
Well, see, this is
Different on Windows.
Yes, it is.
can.
The opposite way.
Yeah, if you're trying to use arrow.
Okay. Yeah, that's almost perfect. So, the only thing is that length is a function.
And the function's over 32 over.
So, on your straight now. So, when you're running forward, what happens when the forward's over?
Returns
Then, it's returning the input inside the forward. The main stuff. Then, what happens when the length zero thing down? I'm just asking what happens when the forward goes out? Already one.
One, yeah, okay.
And then, oh, and I'm gonna turn the character over.
When it gets to the end of the,
Okay,
So here, it brings out like.
value.
yeah, but some of these are for stuff I haven't done yet, like that.
I'm talking about.
Yeah, I don't know why they do that.
So
The
if
procedure
there's
works
a
fine
line
if
character
it
in the
passes, but.
return that. Now.
Okay.
Yeah, this one.
Then here.
Yeah.
What happens when the switch is over?
Yeah.
So if there's only one character.
If they get something that, if you get like an input that
Otherwise,
does that.
yeah.
Yeah.
Now, this is why you do the.
Oh, okay. All right, thank you.
You're right there.
So you have 146 of evasion, which was this, right?
Yeah.
Now, what do you return when this function's over?
I'm not sure.
So what I did, when this function ends,
Oh,
that's what I did.
so
Because
that's,
otherwise, the function will just keep going without
I
stopping.
thought, so that's like what, it's like easier to return zero?
Yeah.
Didn't you do like return?
Yeah, that returns the string back out, right? So the function will just keep going.
Or
So,
Because the for loop, once the for loop's over, it just keeps going. So you have to return.
I haven't altered this string anymore.
Outside of the for loop.
I just put the return zero and then catch my thing.
So now it just, like, what about on line, on 96? Okay.
196 is something I've done yet.
Oh, okay. See, now you don't get the return.
Figure out how this applies to outputs, right?
No space, I think I joined a programming one,
It's even saved as errors.
Right
here. Oh. That input side?
Yeah.
Should be one, should be I.
Oh, did I here?
No, you do I there too, because you're checking the string at that point.
Did you have a one?
No.
Oh.
So try running that again.
So,
See out?
yeah,
Or you need to output it.
don't think to like output. No,
See, with the problem here, you're returning input, right, at the end of the for loop. You're outputting this to the console. You don't need to do that. See, we don't even need the beginning portion here. Right? And you just
I
want,
was trying to do like from memory for when I was looking at yours, because,
so basically what you want to do here is you're saying input
okay.
at 0. So you're saying at that string at 0, you're going to lowercase it at 0.
What I was initially doing was maybe like a function similar to this, but it ended up not working like we code.
All right, go back to the code. Now make it.
And that's why I was kind of struggling.
You added up here. There it goes. Unsigned unsigned int. So mention function. Unsigned int I is 0. I is less than the input step up. You did that, put it dot at I, so you're saying like 0 is lowercase n at 0. Return input. You're returning the input at the end of the loop.
Don't you do that?
So every single time it's run, you're returning the input. Let's move that. Maybe we should move that up. So now when you run the for loop, it'll lowercase all the letters, and then once this becomes false, then it will output input.
Alright. Just tell me to make 0 again. Okay, make 0. Return 0.
I don't think so. The reason why we return 0 up here is because once this is all over, it should just close. It should have, at least stop. Alright, right? Now for this one stops because you're outputting the string that it wants. So you're just returning input. So you have an error here. Error? What's error? No matching function for the call.
That's 181. Never mind. This video.
181. It's right there.
Yeah. I missed where it's 181.
So especially if you start like writing out like individual letter and proportional.
I'm just. Last semester, I was really getting, I knew when we had to put it in for my stuff, and make sure that like, inputs didn't get fucked up, but like, you make a mistake that would like kill them.
That's on your streams. So this is what I have for the function.
It's about the same.
Yeah, looks the same. So you have unsigned int I equals 0, and then semicolon I is less than the input size, semicolon I plus plus. Okay. You say input dot at I equals 2 lower input size, or input dot at I.
What is it supposed to do? Input dot. That's probably what it was.
So what you were basically asking the computer to do was to check the size and then make it 0. And then you made the size 0, and then it returned 0, and it was freaking out. So try making that again.
So you get for trying to do stuff from memory.
Yeah, then now run it. Now it will work. Now you're passing the test.
Alright.
But you're still, this program is still breaking somewhere. Well, I didn't even put stuff in those functions. I just made the get character function, which is at the very end, and then it ran all the tests and failed. It's just that once you get down into those functions, it'll just break because it's missing something. Yeah. John, do you want the stream to care?
Dot, and it's gonna push your whole directory where you're at.
Yeah.
It's gonna, unless you don't want to push through.
I don't want to push through because I didn't, like, I have that done and I submitted it. And it's saying that changes but I think it might have been, because I opened it up, it's like it was open, and they,
CD.
You're just returning what's there, and it'll just know it's a character?
And just do it.
Well, if it's not a character, you'll just.
Oh, so it's checking for one
Yeah,
character.
first you check to see.
Yeah, I did that.
Yeah.
And then, I just did less than or equal to 0.
Yeah.
And then, yeah, so you just return the value at that point, And then, actually, I'm wondering if he tried to input like a number or something, it would still output a number. But it doesn't matter. It doesn't matter.
Did you get to the last one, or is that the one that you're on?
Oh, it's just on string to char. I gotta move to the string to double and then string to bool. So I have to run the program to see if it passes that test. For some reason, it's not home. Oh no, I have to reload the workspace.
Yeah, I'm not passing the bool.
I'm trying to think how that's gonna work. So you would check to see if they put a T or a lowercase t, and anything else fails. So if they input anything that isn't a T or an uppercase T, it fails. That would mean it's false.
Yeah, I tried making like an if statement, but it didn't like it. So.
On strings.
Sorry.
Yeah.
What?
I'll try that.
So it does work on.
So on strings, so regular strings it works. Okay. But it could be. Yeah. Value.
Aha. String to double is failing.
Strings name value.
Because I didn't even make it yet.
So you also can't make, I can't make another variable. Right. No, strings the type, value is the name of the parameters. You want to say value at.
Alright, so let's back. The project? Yeah, you have to, so in the project it talks like in that.
Is that where you get full file?
Yeah. But if you haven't set up, so we set up the things. Yeah, okay, so, readme is the easiest way for us to do it. Just copy this back here. Could be, I sent everyone out an invite on GitHub to have access to that repo, and if you didn't accept the invite.
Yeah, and I accepted.
Okay, so. Is that what?
Yeah.
I have no idea, because they're literally from the same history, because they're copies of each other. We say allow. Yes, by their assignment or assignment one size.
Alright, so I think I already started on the issue.
Class is not here, but you get it.
And then,
Do that.
so what you did last time too, because last time I did that, it said class already existed.
Oh, yeah. I haven't touched nothing.
Well, no, because I was having the issue for that. So
But
then,
now if you try it. So what happened, because I did that, this is what this is saying. So because I did the, I forced them to sync together, it like, basically it tells you, okay, this is one version, the head is one version of the code, and this is another version. And so they have a hard time like merging the two together. And so
you have to basically, you can see head is your good stuff, right? Sometimes there'd be like other code down here, right? So obviously this one's the bad one, so you just have to go through and get rid of.
But if I already submitted it, do I have to worry about it?
No, you don't. No, you should be fine. It's not found. We know it's there. It's weird.
Yeah, plug that cord. Yeah.
Now you have access to it. Now it should be found. Oh yeah, refusing to allow unrelated instruments.
Yeah. See, and then you did this, and everything just appeared.
Huh?
Because we already had it in the file.
But no, because it's like histories would be like you gotta change the commit histories, and they're all the same.
We gotta change the commit message. That what you're not doing?
No. Okay. I don't know. Maybe we can do that. Let's check out. Okay. Oh, you don't have to go in and like, because we do get status. These are the ones that are here, right? So we got labs.
Yeah, I was just doing that for the web.
Yeah, right? So this might actually work. With all the crap, right? We do. We know the head one's the good one, so we get check out on the head. Oh, look at that. That's much better than Delusional.
Yep.
Can you handle better than the rest of them?
Get, check out,
Yeah, get, check out. You can do it from here if you want. So yeah, get, check out. Space, yeah, space. And then you have to get the whole full password, lab/4. That's not gonna work. Do check. Let's try to get status. Thanks for everything. Yeah.
Also, it
Work for all of them. Yeah. The readme still active. We went in the last one.
So because you have to separate everything by space.
Which is good enough. Now you
so really you're just doing the classes.
Tonight all update. You shouldn't get the unrelated histories anymore if we like merge them all together.
I was gonna ask you, like I still have those two big projects.
Okay.
I'm trying to work with JavaScript right now.
Okay.
I'm just studying some of these side contracts, but it's weird to be working with
Java or JavaScript?
No, I'm working in Eclipse, so I'm gonna walk you through this. I know it's there. I just like.
Do you create variables with like string and int still, or do you create variables with here? So like. Java's gonna look like this. So they do a lot of this public class. Everything starts in classes. Program start in main, and they have like things like this, right, and that kind of stuff.
Oh, I know it doesn't have to work classes. And then the classes and stuff like that.
And that doesn't go. JavaScript. It's a lot different. JavaScript.
JavaScript is really close to
Java's a lot like it's a lot like C++. That's good. That's good.
Yeah,
It's just more wordy.
I'm starting to learn it, but it's also like
Just
The
enough.
autofill is helpful, but it's also kind of annoying.
Yeah, it's too much.
Well, and then sometimes like you'll do the autofill, but it won't reflect what it needs, so you have to go back and then check your line.
Right.
And that's why I kind of feel like they could have done that better.
Yeah, it's still used a lot of places.
Should I even switch?
You can
I don't really want to.
Okay, I mean, you can still have an if too. This is your string goal. So you have a value, and really you only care about what the first letter.
Right.
So it's gonna look pretty nice. It's gonna look a little bit like this, right? Because you want to make sure it has content, right? So the length has to be added to this one.
Oh.
Right? And then if it is, so you can just nest your if statements. So like if the length is greater than or equal to the text numbering, right? Then you need to drop if value at 0.
Do one if after another.
Exactly.
Oh, inside?
That's why you said,
So you can do
like universal.
like structurally. If right, and so that you offset it.
Oh, okay. Yeah.
So this would be like if the length is at least 1, right? And then if it's a t or not, right?
Yeah, is value at 5?
Yeah, right, there you go.
Okay.
It's value at 0.
I don't even think that, like,
Okay. Sounds good, thank you.
What? I passed all the tests and stuff, right? I didn't even write anything in the string tool.
Yeah, that's when I was working on part of it and I ran the test, it like passed most of them.
I mean, the only reason it would stop is
Probably because it like had a value assigned to it that made him test.
Did you just copy and paste from string to in, string to
Will you see it?
or did you actually?
well, because none of the functions should be used.
No, he already had the function in it, so I just.
You just copied
It should be in there.
I
Change
didn't,
them, but I know.
I didn't paste it, but I like typed it in.
So Luke, I have a tiny problem.
Okay.
I didn't write anything in string to bool, and I passed it.
No, that's probably because you got lucky.
Uh,
Because remember, it's either gonna be true or false, so just. Oh, but
yeah.
notice it says check line, so it says
Yeah.
pass, but it didn't really pass.
Okay, because when I make the file, it does give me warnings. It just
Right.
tells me they're unused parameters. Or
Yeah,
yeah.
so just write it, it'll be good.
Okay, I will do that.
I find Python on the computer so much.
Yeah, so all of this is all this is all just stuff I did first time.
Like Smash actually.
Oh.
And actually, like C++.
Yeah, and for string is
So much C++.
I did that the first thing. I made a character because I didn't know that I might be I tried it and it worked.
Okay, well, I'm gonna do it.
The only thing that goes with you.
I was like, I was thinking of something you get to do that function. I didn't algorithm this, but I had a video in my class who did the brute force method. He literally programmed every single possible response for as a call function. So like he like sometimes it calls work, you know, 7 goes 2. It works though, you know, it works.
as it's been since I last took a class in HTML, I've been that. And then understanding HTML more.
One of the other thing that I noticed is really bad is like trying to do anything on my without you understanding on your own is like code styles. You want to make a video, stuff like that, and then I have to go back and fix that stuff.
Streams are empty when created.
Unless you in the parentheses attach stuff. Yeah, maybe call me something.
I guess like.
Minutes from.
Ain't bad yet, but I know.
Okay. Mainstream upstream label, separator value. I think you're just missing these also bias space.
Oh, each one of them.
It's using spaces.
Oh, okay. Probably pretty much.
So if you could see it, yours would just look the same. This just would be no spaces.
I just needed spaces in between each one.
Yeah.
Programming pretty awkward.
No, because it's a junior level class.
Okay.
So you can, if you're going to be around, there is that program that allows you to take GeoState classes while you're still at U for free. So I'd have students take 311 while they're still finishing up like physics and math.
That would be really nice, because I was looking at that, and it's like required for my ASC, and I'm just like, it's required, it'd be great if they offered it.
Yeah. So yeah, 311, yeah, I got GeoState. But Transfer Counseling Center has all the info on how you do that cross-home Chico State. So they can set you up. I think you take two, if you know you're going to Chico State, it depends on what you're transferring to. If you're transferring to Chico State, I think you take up to 2 classes.
Yeah, it's like,
A year for free.
Programming free, talk to
Yeah. Transfer, go to Transfer Counseling. Doesn't matter.
So I don't think it matters at this point, I'm starting to pick up the rest of my classes on my own.
I can help you out with all that stuff too, but as far as that program, they have all the
I
paperwork.
mean, trying to understand why the test for the first two, the big papers works, but the test for the second two just crashes. And
Okay.
this is what I have for the function
Input at carrier index. Okay, and what does it tell you about in the thing?
in here. Character containing, a character containing the character for the empty string, a character position, or the null character.
If what? Null character of what?
Character is outside the string.
And so when could carrier index is outside the range of the string? Right, because basically I'm giving you a string and then I'm giving you an index, right? So if it's negative, that'd be a problem, right? Because if I give you a string and I say I want the thing at -5, that's a problem, right?
Yeah.
Or if I give you a string that's got 5 characters in it and I say I want it at position 100, that's a problem, right? And so what's happening is it's crashing because in that example, I give you one where the string, the string's 5 characters and I say I want character 10. So you need some error handle. So you need some if statement around that.
Okay.
Right? You're only going to return at carrier index if
That's
it's
what
in the
I
index.
originally did. I thought, I was kind of struggling today, I didn't really understand what I was supposed to do once I got the if part. So, for the if statement thing in the parentheses, this part right here.
Greater than or equal to 0 and the length. Remember, the length is a member function, right? Change that here.
Or size?
Yeah.
Rule?
Yeah, even in the docs, it's the same thing as this.
It's not like that.
Should there be parentheses for that?
For length and size, you wouldn't pass it. Yeah.
I mean, why?
I mean, just all functions have to have parens regardless of being passed.
I see your guys.
So a lot of empty, you don't do anything.
It's just like formatting for C++.
I don't know. And a lot of languages. To differentiate, right? If you think about it, variables don't have parens and functions have parens. So it helps differentiate your kind of well.
Oh, I think I got it from John.
And well, I then need spaces, but also that in my, I And then mine at the end of I messed up the following 2 tests as well. Already done. Oh, maybe it's the same thing.
Literally, it's not.
Out of range? Oh.
What do you mean? What language or what? So, if I was gonna make an app.
Like, according to CS, because only where we know is from here to here, which uses the double.
Because then it's cross-platform.
Oh, and return.
The web stuff that you learn in class.
So I'm like, I'm not sure if that was intended, but I'm just gonna work with it.
Right, so I think
Because it works.
It is a framework, and I'm pretty sure React Native is written in JavaScript. If I'm not mistaken. And we might, if that's what you're interested in doing, we can make that your thing.
Do you have an idea for
So
both?
React is.
I tried this, or it would check the value at 0.
Yeah,
which would be
I
the-
tried at 0 and it didn't like that.
It freaked out when I did it.
Well, doesn't the single equal sign mean it is and not equal to? So you're saying if value adds 0.
So,
Yeah.
yeah, that's what you're interested in. I
Oh. Huh. Oh, it broke. Out of range. Oh, it's out of range because he inputs a blank string. Luke, you are quite clever.
Usually I am.
You put in a blank string and that broke my program.
I pretty much try to figure out what's gonna break it and put that in.
And then you just change the unit test so it matches his work.
You just, if it's putting in something blank, couldn't you just
You
add
actually write
something
no,
to this and
you
put like,
write no code.
or
all your
if
code
it's
blank string.
The size of the string, the size of the string has to be greater than 0. Yeah.
Is that all you do, right? Because.
That's what the test does. That's not what I do. I look at it.
Yeah.
Or have my grader look at it, because you guys aren't worth looking at that. That's
Grader real small.
Smart man, you give him $100.
Yeah, right? Right. That's the same thing. In Canvas now, graders can't be anonymous, so you like find out who my grader is. Careful. Please don't break it. I'm gonna keep out of those guys.
No, I like the up desk.
I got a really tall desk. Mine goes up too. I can get a little bit.
I said and the size has to be greater than 0.
Oh yeah, we got fiber in our house, so I don't have any floors.
Greater than or equal?
We got fiber last night, or yesterday.
Oh, that broke it.
I meant on Saturdays.
It says you're not allowed to have an and with an or.
Is that their U verse?
Really?
Is that what they
Yeah.
call it? Or
You can't have both. Parentheses around the and within
Well, yeah.
or.
Satellite, isn't it?
No, it's still off of that. No, it's
Oh,
still
you're
off of
gonna
that.
make me do the,
Or?
you're gonna make me do this.
It's fast as hell. I gotta get a gigabit card for my thing. We've got Cat 6 running my computer. computer upstairs, like 75 feet, and I'm seeing about 6 by 900 or something like that. I need a gigabit card though, to see up and down. But over 75 feet, that shouldn't really slow down the internet, would it? Or would it?
No.
Not now.
Not really, no.
Maybe I could quality.
Oh no, it's the cheapest shit from Walmart. That was like half the price one. That's bad.
It's still not gonna slow it down. I wish I could run into slow down. It's like, yeah, you're running over 300 feet. It's 330 something.
Oh, you just do this.
So I mean,
Yeah,
every winter, you're gonna have to feet a little.
Yep.
But isn't that glorious? That's exactly what it's just a network test. Hey, isn't that glorious?
How do I check to see if an input is nothing? How do I check if an input is nothing? I said else return 0, but that broke it.
Couldn't you just, instead of doing like size, couldn't you, if value at 0 equals, and then just put like a blank string and see if that works?
That'd be too complicated.
Like up here. Just do another OR and put if value at 0 equals blank string. So just put
If it's a
them.
blank string, it's false. So
Didn't you say that's what was?
okay, let me do this. Else, if
I hope so. Yeah. This class isn't too bad.
Yeah, I hope so. It seems like it's not as bad as program 2.
You just had to throw them out.
You
You just had to throw them that blank.
You just return the button.
You didn't want to know that's like true or false would be better. All lowercase. True.
But that's that. To change the color.
Yeah. Yeah, if it's not, then it doesn't.
It didn't work.
the size of a string cannot be 0. Oh, what? Oh, I messed up. There.
Boy, it's still not.
Aha. Progress.
Have you graded lab 3 yet?
That didn't work.
Okay.
You're like, that's
Freaking out because it says
Exactly.
called after throwing an instance of out of range, basic string, which is 0, which is greater than or equal to the size, which is 0, aborted.
What happens if you change the value dot
I wonder if I
after?
got at the tail end of the bumper to bumper. The class that started at 8, like that 750 and like 805 times something like that. So kind of timing a little bit better.
I passed probably a good 100 cars.
Yeah.
Because it says the string is.
Something I don't like about this compared to
Oh, yeah.
make style.
Hold on, let me
You
try.
don't like mixed out?
I know we have to narrow it down to that.
The good news is you'll get used to it and then you'll just write it and it won't even be a problem.
But I have to get used to it.
Yeah, yeah, get used to it.
I don't want to.
Yeah.
Lab 4 is until Thursday.
Correct, yeah, yeah.
I do it close enough.
I was a little about 5.
There's one time? I didn't see it on.
It's there. You might just have to hold it down.
Do we have to pull more? Because do we have to pull more from the
You
GitHub?
will now. Right, so I only needed through lab 4 on that first pull.
So I have to do it again?
I have to set that and pull on the new one.
Luke, I have one question for you over here.
Let me get through that.
Okay.
I think it's been two semesters. I realized I'm rusty and a lot of deals with
Funny.
So my favorite website is learncpp.com.
John, you have a good rest of your day.
So learn.
Alright. Now we can make again.
I realized that the first couple labs I had so much reading time through I got to lab 3 and started having issues.
Yeah. Yeah, it takes and which is why we're doing something like this kind of.
Learn what?
Learn CPP. I like how that website's laid out.